1.1 Solving simple equations. An equation is a statement that two expressions are equal, and you normally would see it with a equal sign. Now, a linear equation in one variable is an equation that can be written in the form of ax plus b equals 0, where a and b are constant, okay? They are a rational number. And where a cannot equal 0, meaning if you replace with a 0 times x, then your statement will not be true because b will not equal 0. Solution of an equation makes this equation true. Okay, so that's solution of an equation makes the statement true. Now we're going to be working with inverse operations. Okay, that means it's two operations that undo each other to create an equivalent equation. So for example, if you have addition, the inverse will be subtraction. That will undo it to create an equivalent fraction. So the inverse of subtraction also will be addition. So we're working with addition property of equality, which that means that you add the same number to each side of the equation to produce an equivalent equation. So A equals B. If we add C to both sides, okay, so what you do to one side, you have to do it to the other side. You're going to create an equivalent equation. Same if you were to subtract it. A equal B, which is your subtraction property of an equality. You to subtract C from both sides, A minus C equals B minus C. You create an equivalent equation. Example 1, solve an equation by adding or subtraction. Solve each equation, justify each step, check your answer. So in step 1 here, we're going to x minus 3 equals negative 5. We're going to write the equation. We're going to use the addition property of an equality because we have a subtraction over here. So to undo this, we're going to add 3 to both sides to create an equivalent, okay? To simplify, we're going to have x because this cancels out, correct? So x equals negative 5 plus 3 gives us negative 2. So the solution is x equals negative 2. If we were to check it, all you're going to do is substitute wherever x is over here and for negative 2. So we're going to have negative 2 minus 3 equals negative 5. Negative 2 minus 3, if we were to add a plus sign right here in the middle, we know that when we're adding two negatives, we're going to have also a negative. So our answer is going to be negative 2 plus negative 3 gives us negative 5 equals negative 5. So our solution is correct. In B, we're going to write the equation, which is 0.9 equals y plus 2.8. Oh, we here have a addition, right? We have a plus sign there. So we're going to use the inverse, which is subtraction property of an equality. So we're going to subtract 2.8 from both sides, where this cancels out. We bring down the y and we simplify with 0.9 minus 2.8. We're going to be left with negative 1.9. The solution is y, I'm sorry, I was going to write x. Y equals negative 1.9. To check this, do the same thing. 0.9 equals negative 1.9 plus 2.8. In this case, 1.9 plus 2.8, which is negative 1.9, we're going to have 0.9, and our statement is true. So remember, we have negative 0.9 plus 2.8. Think which is bigger in number-wise, not with the negative, will be 2.8. So that means we're going to have a positive. Then you just subtract normal. 2.8 minus 1.9, which is 18.910. And that's our answer. Solving linear equations by multiplying or dividing. Remember that multiplication, right here, multiplication and division are inverse operations, similar to the subtraction and addition. Now, when we multiply each side of an equation by the same non-zero number, so we cannot multiply with 0 because if not, then it just be 0 equals 0. We create an equivalent fraction. So if A equals B and we multiply C to both sides, so A times C equals B times C, we're going to have an equivalent equation. In division, same thing. If A equals B and we A divided by C equals B divided by C, we're going to have also an equivalent equation. An example 2, solve an equation by multiplication or division. So in A, they're telling us to justify each step and check our answer. So in A, we're going to have to first write our equation. So we have A negative n over 5 equals negative 3. This case, we have a fraction, which is the same as division, correct? So we're going to use the multiplication property of equality. So if we use the multiplication property of equality, we're going to multiply both sides by negative 5. So we can get rid of that fraction. So we multiply by negative 5. Let me write in another color so we can see it. Okay. So now these cancels out and we're left with n equals negative 3 times negative 5 gives us positive 15 once we simplify. That's our answer. Let's check it. All we have to do is substitute where n is, which is 15 over 5 with the negative here, equals negative 3. 15 divided by 5, we bring down a negative, gives us 3. Negative 3 gives us negative 3. And that is our check answer. In B, we're going to write, we're going to write the equation, which is pi times x equals negative 2 times pi. So we know we are multiplying here, so we're going to use the inverse division property of equality. So we're going to divide each side by pi, because remember we're solving for x. So if I divide by pi, by simplifying, we know that this cancels out and this cancels out on both sides. So x equals negative 2. To check this, we're going to just substitute wherever x is at, which is pi times negative 2 equals negative 2 times pi. And we know that, for example, 5 times 6 is the same as 6 times 5. So this is negative 2 pi equals negative 2 pi. So they're both creating equivalent fraction. In C, we're going to write the equation as well, which is 1.3. The C came out a little crooked. Let me rewrite it. 1.3 Z equals 5.2. This is a multiplication. So we're going to use the inverse, which is division property of equalities. So we're going to divide both sides by 1.3. 1.3. This one cancels out, and I'm left with z by itself, which gives us 5.2 divided by 1.3 gives us 4. Okay, so even if we work this out, we're going to have 1.3 divided by 5.2. Move up decimals. So new decimals over here. And we know that this will create 4 groups, which is 13 times 4 gives us 52. Okay, that's where we get 4. Checking our answer, we're just going to use substitute. 1.3 times 4 equals 5.2. Checking 1.3 times 4, 12. Bring down the decimal. 4, 5. So 5.2 equals 5.2. Always remember what you're trying to solve for is the variable. So you always want to isolate, okay, the variable. Okay, example 3, modeling with mathematics. Okay, so different 4-step approach to solving problems. Understand the problem. Okay, understand the problem. What is the unknown? What information is being given and what is being asked? 2, make a plan. This plan might involve one or more of the problem-solving strategy shown. So, for example, you can create equations or expressions to help you. Okay, solve the problem. Carry out the plan that you're going to solve the problem and check that it's correct. And then always look back, okay? Always look back just to check that the solution makes sense, okay? Makes sense. Just like in real life problems, you always check back and double check just to make sure everything is correct. Okay, so let's use right over here this example, modeling with mathematics. So in the 2012 Olympics, Usain Bolt won the 200-meter dash with a time of 19.32 seconds. Write and solve an equation to find his average speed to the nearest hundredth of a meter per second. So if we use the steps, which is understand the problem, okay, understand the problem, you know the winning time, which is 19.32 seconds, correct? Of the distance, okay? The winning time and the distance of the race. So we know the distance is also. So we have time given, which is 19.32. We also know the distance, which is 200 meter, correct? So we are now being asked to find the average speed, okay? So average speed to the nearest hundredth, okay? So that means after a decimal point, 2 places, correct? Per second. Okay, so this is what we need to find per second. So we found what 1 is, okay? We understand the problem. Let me move 1 over here. So we could see we move 1 over here. Now in 2 is make a plan. If we know we're dealing with distance, it tells us right here, right? We're dealing with distance. We should use the distance formula, okay? So in the distance formula, if we recall, it is D equals R times T. Okay? So we're going to rewrite the distance formula. We have already what D is, which is 200, okay? We're going to solve the problem now. We know that 200 is the distance. R we're going to use to represent rate, okay, which is going to be the speed. So R is going to represent the speed, which is the rate. That is what we're looking for. So we do not know what R is. Times T. T is the seconds. 19.32. Okay, so we substituted 200 for D and 19.32 for T. If we were to solve this, we're going to divide by 19.32, and we're going to find it to the nearest, right, hundredth. It's given right here, nearest hundredth. So in this case, it's going to be 10.35 approximately, okay? So this symbol means approximately, equal to. It's not the exact same thing, but sometimes when it's rounded or estimated, we're going to use approximately, okay, R. So both average speed was about 10.35 meters per second.